Welcome. Today I am going to discuss some question of CSIR NET about limit superior and limit inferior. In my previous video, I have discussed what is limit superior, what is limit inferior, and I have discussed some theorem based on limit superior and limit inferior. At first, I recommended you, please see this video with attention. Then today's video will be so easy. Let's see the question. Let xn be a sequence of non-negative real numbers. Then, which of the following are true? Option 1. Limit infimum of xn equal to 0 imply limit xn square equal to 0. This is based on the theorem. The theorem is, let xn be a bounded sequence and S be the set of limit point of S. Okay? Here not S, here xn. S be the set of limit point of the sequence xn. Then maximum of S equal to limit superior xn and minimum of S equal to limit inferior xn. Okay? By using this theorem, I am going to create a counter example of first option. Let's consider a sequence xn equal to 1 0 1 0 1 so on. What is limit superior? One. Okay? And what is limit inferior? Limit inferior of the sequence xn equal to 0. Okay? Have you understood? Alright. That imply limit xn square equal to 0. Xn square mean you need to square every term of the sequence. Okay? But if I square every term of the sequence, what I will get? I can never limit of this sequence xn square equal to 0. Xn square will be same sequence. Here limit does not exist. So, option 1 is a wrong option. Okay? Are you getting my point? Well. Now, let's come back option 2. What is option 2? Limit supremum of xn equal to 0 imply limit xn square equal to 0. Okay? Since given limit superior of xn, limit superior equal to 0, that means xn, the sequence xn must be bounded. Okay? We all of us know limit superior of the sequence xn always greater than equal to limit inferior of the sequence xn. Okay, and notice the question, xn be a sequence of non-negative real number. Since limit supremum of xn equal to 0, that means limit infimum of xn must be 0, because every terms of the sequence is positive. Okay, and we all of us know this theorem about limit superior and inferior. Have you understood why I have told you my previous video is very important? Because I am using here only result, not theorem. I have explained this property in my previous video. Then it will be so easy. At first you see. Theorem on xn is convergent. If a sequence is convergent, then limit superior of a sequence and limit inferior of a sequence always equal. Okay? And theorem 2. If limit superior of xn and limit inferior of xn always equal, then xn, the sequence xn always will be convergent. Okay? Since lim sup xn equal to lim inf xn, which is equal to 0, then the sequence by the theorem 2 must be convergent. Okay? Alright. So, option 2 is right option. Now let's come back option 3. Option 3 is limit inferior of xn equal to 0. That implies xn is bounded sequence. Is it true? Just think. If we consider a sequence xn equal to 0, 1, 0, 2, 0, 1, so on. What is limit inferior of xn? Limit inferior of xn equal to 0. But the sequence xn is not a bounded sequence. Okay? So, option 3 is wrong option. What is option 4? Option 4 tells limit inferior of xn square greater than 4 imply limit supremum of xn greater than 4. Is it true? Option 4 says if limit inferior xn square greater than 4, that imply limit superior xn greater than 4. Is it true? Let us consider sequence xn. Consider xn equal to 3, 3, 3 constant sequence. What is limit superior? Limit superior of xn equal to 3. And what is the xn square? Xn square will be 9, 9, 9 up to so on. What is limit inferior of xn square? Limit inferior xn square equal to similar 9. Okay? And this is greater than 4. Look, limit inferior of xn square greater than 4, but limit superior of xn equal to 3. So, what is option 4? Option 4 also wrong option. Okay, let's see other question of CSIR NET about superior and inferior. Let's see the question. Let Pn denote the n prime number when we enumerate prime number in the increasing order. For example, P1 equal to 2, P2 equal to 3, P3 equal to 5 and so on. And S equal to Sn equal to Pn plus 1 minus Pn for all n belongs to natural number n greater than equal to 1. Option 1, supremum of S equal to infinity. This is important concept of prime gap. It is the well-known set which is known as prime gap in number theory. Now, let's see the element of the set capital S. Given P1 equal to 2, P2 equal to 3, P3 equal to 5. Given P1 equal to 2, P2 equal to 3, P3 equal to 5. And S equal to Sn equal to Pn plus 1 minus Pn. N belongs to natural number and n greater than equal to 1. What is the element of the set? Three minus 2, 5 minus 3, 7 minus 5, 11 minus 7, 13 minus 11, so on. Okay? That means the element of the set are 1, 2, 2, 2, 4, 2, 4, 6 up to so on. Okay? And look, 2 is only even prime number. Okay? And 1 is odd prime number. Okay? In first option says, what is the supremum of this set? At first, I recommended you, please see the video of my supremum and infimum of a set. I have discussed clearly in this video what is supremum, what is infimum. If you see this video, then today's video will be so easy. I have given the link of this video in my description box. At first, recall the definition again. What is the upper bound of a set S? A real number k is said to be upper bound of a set S if small s less than equal to k for all small s belongs to capital S. And what is supremum of a set capital S? A least number if exists of a set of upper bound is called supremum. Okay? Now see the set S. The given set increases. This is never going to stop. That means this set has no least upper bound. So, supremum of S equal to infinity. So, option 1 is a right option. Okay? Alright. Let's come back third option. Third option is infimum of S strictly less than infinity. At first, recall what is the lower bound of a set? A real number k is said to be a lower bound of a set capital S if small s greater than equal to k for all s belongs to capital S. And what is the infimum? The greatest number of a set is called infimum of the set S. This is the definition. Now notice the set. It is very easy. 1 is the infimum because 1 is the greatest number of a lower bound of a set capital S. So, infimum of S equal to 1 which is strictly less than infinity. So, option 3 is right option. Okay? Alright. Let's come back second option and fourth option. Second option is limit supremum of Sn equal to infinity, and fourth option is limit infimum of Sn greater than equal to 2. At first, look fourth option. What is the inferior of the set S? This is very interesting. Look the set. 1 is only single element here and 2 is the smallest number of this set and 2 is here even prime number. We can construct a subsequence with even prime number because 2 is only here even prime number. Then this subsequence converges to 2, and since 2 is a smallest number of the set, so limit inferior of S equal to 2, which is okay. So option 4 is right option. Okay? Alright. And since supremum of S equal to infinity, since supremum of S equal to infinity, that imply the set is not bounded above. Okay? That means limit n tends to infinity, supremum of S cannot be finite. It will be always infinity since the set is not bounded. So, option 2 is also right option. Okay? Alright. Now let's see other question of CSIR NET. At first, I would like to tell you, see this video with attention. Then you will know the strategy how to solve any problem of superior and inferior. Okay? Now, at first see the question. Define a sequence n as follows. A1 equal to n, 1, and for n greater than equal to 1, a n plus 1 equal to minus 1 to the power n half absolute value of a n plus 2 absolute value of a n. Let's first write our given sequence. A n plus 1 equal to minus 1 to the power n half absolute value of n 2 over absolute value of n. Okay. Now I am applying mod both sides. Why I am applying mod both sides? You will understand few minutes after. Now applying mod both sides. Half what I did? I just remove this minus 1 to the power n. Okay? Now my claim S is a bounded below. Here, this interesting thing, Sn plus 1 half Sn plus 2 over Sn. We all of us know M-Gm property. A m greater than equal to Gm. What is the property? A plus b over 2 always greater than equal to square root of ab. Here this is A, this is B. Then from this property I will get half Sn plus 2 over Sn always greater than equal to square root of 2. Okay? That imply Sn is a bounded below by square root of 2. Okay? Now my next claim is, since this is bounded below, my next claim is the sequence is monotone decreasing sequence. Sn plus 1 over Sn equal to half Sn plus 2 over Sn over Sn. Okay. which is equal to half 1 plus 2 over Sn square. Okay, and since from this inequality we have got Sn is bounded below by square root of 2, then we can write this is less than equal to half 1 plus 2 square root of 2 whole square. This is less than equal to half 1 plus 2 over 2. This is less than equal to 1. That means Sn plus 1 less than equal to Sn for all n belongs to natural number. Okay? From this line we can tell Sn is monotone decreasing sequence. Okay, well, that means here Sn is monotone decreasing, also Sn is bounded below by square root of 2. That means by monotone theorem we can tell Sn is a convergent sequence. Are you getting my point? Why monotone theorem is very important? I have told in my previous video. So I recommended you don't miss our sequence in previous video of my sequence. Okay? Since the sequence is convergent, if I apply limit on both sides, then I will get limit n tends to infinity Sn plus 1 equal to limit n tends to infinity half Sn plus 2 over Sn. Let's consider limit n tends to infinity Sn equal to S. Then it will be S half S plus 2 over S. If you calculate, then you will get easily S equal to square root of plus minus root 2. Since Sn is monotone decreasing sequence and bounded below by square root of 2, then minus cannot be possible because Sn I consider the sequence of positive terms. Okay? So limit n tends to infinity Sn must be square root of 2. Okay? Well, notice the question a1 equal to 1 and an plus 1 equal to this sequence. If we write this term, then this will be. What is a2? a2 equal to minus 1 to the power 1 because 1 plus 1. And this is negative. Let's consider other term of the sequence. a3 equal to a2 plus 1. If we put the value minus 1 to the power 2, this is positive. a4 equal to a3 plus 1, this is minus 1 to the power 3, this is negative. a5 equal to a4 plus 1 minus 1 to the power 4, this is positive. From this terms, we can write the even term a2k is negative and the odd term a2k plus 1 is positive. Okay? That means the odd term, since this is positive and I have considered the positive sequence Sn equal to absolute value of n, and I have got this positive sequence is monotone decreasing sequence. That means, and which is bounded below by square root of 2. That means we can write square root of 2 less than a2k plus 3 less than a2k plus 1. And since this is negative, if we check, this sequence will be monotone increasing sequence. And this check is very easy. Let's check this. Why this is monotone increasing? Then a2k less than a2k plus 2. Since this sequence is negative, what will be? This is bounded below. By minus square root of root 2. Okay? Are you getting my point? Okay. That means we have got two subsequence of even term and subsequence of odd term. And subsequence of even term converges to minus. Subsequence of even term converges to minus square root of 2, and subsequence of odd term a2k plus 1 converges to square root of 2. From this line we can write supremum of an square root of 2. Lim superior of an square root of 2 and limit inferior of the sequence minus square root of 2, but here given minus infinity, so this is wrong option. Here limit an equal to square root of 2. Is this correct? Since here I have got two subsequence, then the sequence cannot converge. So this option also wrong option. Okay? Now supremum of an equal to square root of 2. Here I have given a sequence which is greater than square root of 2. So supremum cannot be possible square root of 2. So option 4 also wrong option. Only option 1 is true option. Okay? Well.